So the talk title has evolved over the past couple of months. It used to be 7 tools for your stack, and now it's 11 tools. And actually, I'm not even sure if it's 11, but people keep correcting me at the end of my talk. So if you figure out how many tools are in there, let me know. Short introduction about myself, for those who don't know me yet. I've been working in the IT industry, more specifically the open source industry, for almost, I started in '96, doing web development at one of the first web companies in Belgium. And I did pretty much software development there, web development, wrote in all kind of crappy languages, PHP, Java, C, Perl, name it. And I was always the guy who was putting stuff in production also, because nobody did system administration, and I was the guy with a Linux background. So I was the guy who was throwing stuff onto the servers and responsible for keeping it up running, while actually also writing the code. So I became an operations person out of necessity, and with the evolution we have today, I don't even know what I am. I'm somewhere in between. I write code and I run infrastructures. If you look at my real job title today, once we started talking with American people, you have to have a job title, and they want to have somebody who's a CTO, so we made that as Chief Trolling Officer, because I'm trying to challenge all the people we have, and I'm trying to challenge all my colleagues into building better software and into making systems that are higher available. But my main role basically is doing open source consultancy and helping people to build solutions based on open source software. And I do that at Inuit, and we're an open source company. We're based in Antwerp, in Rotterdam, and in Kiev. And we're about 40 people strong now. So, and some people might know me from the title of my blog, which is Everything's a Fucking DNS Problem, which some of you probably already ran into. So, 7 tools for your DevOps stack. First thing you have to do is define what DevOps is. Who knows what DevOps is? Or who thinks he knows what DevOps is? Wim, what is DevOps?
You want the Wikipedia definition?
The Wikipedia definition with commercial vendors, which we tried editing off there? No, thank you. Actually, DevOps it's a movement. Ages ago, well, a decade ago, I was visiting a lot of conferences, talking to a lot of people, talking to a lot of system administrators, talking to a lot of developers. And there was a bunch of people that were constantly running into each other, like Patrick Dubois, Gildas Lenadin, John Allspaw, Julian Simpson, and Luke Kenies, and a bunch of other people. And we were always discussing the problem if you have a bunch of software developers and they write code, how do you manage the flow to actually get that stuff in production? How do you keep that running? And in the States, you have Velocity. Well, I think they have that conference for 4 or 5 years now. And they actually have the place where you bridge the gap, where they have both developers and operations people in the same conference. And those people start talking. They start discussing how to deal with delivering software. But in Europe, we didn't have anything. So back in 2009, Patrick and I were discussing, actually at Cloud Camp Antwerp in the zoo, like, well, maybe we should do something in Europe, and maybe we should actually do a conference with that topic. And that was the first event, which was called DevOps Days, which Patrick coined as a name. And it was in Ghent in October 2009. And it was a really small conference at the IBBT. I think we had 60 to 70 people there, but everybody was discussing the same problem. We had a format where we had 4 formal sessions in the morning, and the afternoons were open spaces. And for a lot of people, that was the starting point of the actual DevOps movement. That was the point where they had a conference like they never had before. They were able to discuss the pains they had, the solutions they were looking after, the solutions they had found with people with same interest, with same problems, with same skills. And it was a mix of developers and operations people really trying to understand how to deploy software in a better way. So we had a conference in Ghent in 2009. We have typically one in the States and one in Europe every year. Although this year we already have like 8 events lined up for the next couple of months. We have DevOps Days coming up in London, Amsterdam, Paris, Berlin, Austin, Atlanta. I'm lost count. I'm basically getting flooded by a mailing list. So it's a group of people trying to solve a problem, a common problem. It's a growing professional movement. And we definitely don't have all the answers yet. We definitely don't know how to solve any problem yet. There's a bunch of problems we solved. There's a bunch of problems where we think there's a good solution out of that. But we still see a lot of problems that need to be tackled. And we've been doing this stuff for ages, since before the name was there. And what we're doing now, since like 3 years ago, we are actually trying to reach out to different developer communities. The first ones were at DevOps a couple of years ago. We've been talking at different Ruby conferences. We're talking to you guys now, doing PHP. So we are trying to bridge that gap between developers writing code and operations people figuring out how to actually do that. So you really want to have a good definition, right? I'm going to read that. Who knows this? Who thinks this is wrong? So I see there's a broken image there. There should be a picture of a really old guy. This is actually Deming in 1986. So there's really nothing new about the movement. There's really nothing new about what we want to achieve. We basically want to improve the way organizations work and do that in a software fashion. So that's still not a good definition. Luckily, some guys who were active in the initial movement, John Willis and Damon Edwards, they actually coined DevOps as a keyword, a 4-letter keyword. They called it CAMS. And they said it's about culture. It's about how do organizations work? How do they interact with each other? How do they treat the people that work for them? And how do they deal with failure? Stuff like that. It's about automation. And with automation, we mean automation in every single point. It's about development automation, it's about build and test automation, it's about continuous integration, continuous delivery, it's about deployment automation. It's about being able to just at one push of a button, basically doing one commit in a source repository and having the stuff in production, fully automated and tested. But it's also about measurement. It's about measuring what's going on your platform, measuring the number of bugs you solve, measuring the number of issues you have in the code, but also measuring the number of users, measuring the memory usage you are doing. And that in order to be able to create a better feedback loop between developers and operations people. And it's also about sharing those experiences, sharing how do you do this, publishing that open source. Over the past 6 months, Gene Kim has been adding the L to the CLAMS word. He has been looking at the influences we have from the Lean movement, and basically that's where some people are starting to call it CLAMS right now. So let's talk a bit about culture. If I look at, sadly, still some of our current customers, but if I look at how stuff was being done 10 years ago, I still vividly remember a customer where I was working, and we were building a brand new website there, and certain Friday afternoon, some developers came to me, you know, here's the tarball, there's a television commercial going live at 7, make sure it's in production. What? Who remembers those days? Yesterday, yeah. Yesterday. So the culture that happened there was basically, this was the relation between developers and operations people. And for, sadly, way too many organizations, that's still the relationship. It's a mud fight, it's people throwing stuff at each other. And honestly, sometimes I cannot really blame those developers because we had books like this. hello, what's your username? You're low on disk space? Oh, that's solved. And lots of operations people were actually taking pride in knowing these books by heart. So what do you expect? That developers are going to be cooperative and going to work together with you? The whole idea about the DevOps movement is that we need to start to work together better. We really need to break down all the silos. And let's face it, developers and operations people, we're all just little kids. We all have fancy new toys. There's lots of us who have new tablets and new phones. And if you have small kids, if they're really small, like kindergarten, they're like playing alone in a corner and they're sitting there and minding themselves, playing a bit. And when they grow up, they actually start playing together. And it's much more fun if you get to play together. It's much more interesting if people can actually build something and get to do funny things together. So let them play with their trains together. So you need to have a tool to actually achieve people to work together, communicate better, and talk to each other. And what's the best tool to do that?
Communication.
That's not really a tool. You really want to have something that helps people to talk to each other and open up and lighten up and... Obviously, beer. Funny thing, everybody likes this, and if you're talking in other countries, they're like, oh, really, Belgian beer. But it's a fact that the DevOps movement was started in Belgium, so I can't help that. We like Belgian beer. So culture is a really difficult topic to tackle. Beer helps, but it's sometimes not really the best solution. But having a hangover with the guy sitting next to you, with a developer, the next day, well, you start talking about other things than bashing about the bugs they wrote. So let's talk a bit about automation. There's a lot of stuff that we call solved solutions, solved problems. Gone are the days when people go to a data center, push in a CD, wait for a couple of hours, push next, 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 and then go home and hope stuff works. No, we automate the deployment of servers. We have plenty of tools to do that. We can choose the tools. There's a lot of open source tools that help you there. We've also pretty much solved the problem on how you manage 1,000 instances of those. Well, lots of people have solved it. Lots of people still need to figure out that these tools exist and that they can use them. But there are still a lot of challenges. How do you do decent software release management? How do you group software from different sources together and make sure that's a coherent functioning package? How do you actually manage repositories of different software versions and make sure that you know what's deployed on your infrastructure? And other tools we have to do, other things we have to figure out is, if I want to have a data center and I want to deploy stuff on only those and those nodes, how do you do that stuff? Those are still tools where we really need to figure out how to do that and improve that and get the tools much better. There's lots of work going on there, but we still need to figure out and improve those tools. So, build and release management. If you're talking to a Java group or PHP people or C people, yeah, obviously, you build software. You compile it. But who compiles the software here? A couple of people. I've got a great tool that helps me not only to compile software. Jenkins is an open source continuous integration server, and it allows me to actually make reproducible builds of my software. And with a build, I don't only mean compiling it. For a build, for me, it's also packaging it, versioning it in a way that I can redistribute software build, redistribute the pieces of code that we have defined as a functional, complete set together. Lots of people use it to test their code, to package it. There's a zillion plugins, well, according to the Jenkins site, 400 of them. If you look at Jenkins PHP, there's a bunch of PHP-related tools which you can use. And that's one point where we have a tool where developers are using it to test their code, to do code coverage, to figure out how many lines of code they have cut and pasted from other places. But the same tool is being used these days by operations people, because we are now also writing code. It's different languages, but we write code to build your infrastructure. And with the same tools, with the same workflows, we are now testing that code and figuring out how that works. So if you look, for example, at a Jenkins pipeline, and this can be any language. Where's the button? Yeah. So this is, for example, the first part of a pipeline where you check out your code from source control. Who doesn't use source control here? Either we're all afraid or we have achieved at least something. Trust me, there are audiences these days where there's half the audience saying, what source control? So we check out stuff from source control. We start running syntax tests. We start running style tests. We package stuff, and then we upload it to a repository from where software can be installed. And you're asking me, why do I need to package it? Who packages this PHP code? Win? Some people? Sometimes. So operating system packages give you a lot of features. They give you the fact that you have unique traceability on where a file comes from. You can implement dependencies in there. You can actually figure out the history of a file and use it to do upgrades. And it's much more easier to actually send somebody an operating system level package and pointing them to a Git repository, because the Git repository in environments where I've been working is not always accessible. I'm shipping software over satellite links to really distant versions, distant locations in the world, where bandwidth really is not something you cannot copy it. It's not that trivial. Sometimes when you're deploying in corporate environments, you don't have access to the version control repository. So what are you doing? Tearing it up somewhere and throwing it over the wall? How do you trace where files come from? If you use operating system level package, you actually can figure out where files are coming from. And it's a little over it to actually do so. And I'll show you a tool that allows you to do later. But there's a much more important part. Packaging software is the point where a developer and an operations guy have to sit together and figure out what needs to be in the package, what dependencies there are on the software. You need these, and these libraries? Where did you get them? How do we make sure they are on the platform? And that's a point where you can actually start the conversation between the people that are involved in writing the software and deploying the software. Oh, and one small reminder, config does not belong in the package. Config is something that needs to be managed outside of a package with a configuration management tool. Now, packaging is something a lot of people hate. It's hard. Anybody here who ever tried to write an RPM spec file or Debian rules? You like it? Yes, somebody said yes. Yes. Oh, Gentoo packages, yeah, fun. So there's this guy in Santa Clara. He's called Jordan Sissel, and he's an expert in anger-driven development. So when he's really frustrated with something, he starts writing a tool, and he calls them fucking package manager. Because he thinks packaging sucks for a lot of reasons. And well, he's absolutely right. Trying to get the right version of a piece of software upstream in your distribution, that's already going to be a pain. Or having to use the upstream version, or having to use something from a different repository. Anybody ever read Maximum RPM? It's a good book, but it's a bit too heavy to really get into it. But packaging is needed. So Jordan wrote a tool which allows you today to basically take any piece of source. By the way, peer is missing in the figure, but it's actually supported. So he basically takes anything, Ruby gem, Debian package, Python, whatever, a directory, a peer package, whatever, a Perl cpan package, and he turns it into something that's usable in an operating system. And it's really trivial. It's stuff like target is RPM, source is directory. I'm packaging Hornet queue here, which is a queuing server. That's the version. And whoops, out rolls a package. No spec files, no magic, that's it. It's really easy. We've actually set up a Git repository where we are automating the build of Ruby gems. We could do the same for peer packages, but we needed this. We had a dependency chain where we needed Ruby packages, and if you need a new package to be built, you just fork the GitHub repository, send a pull request, and about 10 minutes later, if we merge the pull request, out rolls a package which you can install from a repository. It's so easy. So now you have packaged software, which is good, because now you can actually tell on a system which version of the software is there. For you guys, I have the experience of doing this with Java people, explaining them how many different versions of GDKs they have. But it could actually also end up being useful for PHP people, figuring out how many versions of PHP they have on the system. So that's a new tool I needed. And that's Marionette Collective, M-Collective. It's kind of, it's SSH on steroids, but it's much more. It allows you to query your infrastructure, like figure out which version of software is there, where's my Apache running, restart my Apache, clean all my SSL certificates, remove some files, add some files, and do that at scale. You can group them in different groups. You can say data center 1, data center 2, data center 3, do this on all the machines which have Apache installed, do this on all the machines which have Nginx installed. And it's so easy. You're not writing script files anymore. It's much more easy to do that. So one of the examples is on what boxes who are in my acceptance environment do I have Apache running? Well, a bunch of them. This is actually the query of the GDKs, and those guys were telling me we have one GDK. No, you don't. But it was a point where with this tool, we could start a discussion. We could start talking to each other, and they claimed based on, well, we have the ID, we have one version of the GDK. Now, well, let's figure it out. Why do you have so many versions? Do you need that? And people started figuring out and worrying about what they were doing. And now we have tools to help that, to get to real facts rather than some weird ID. And that brings us to actually measuring and monitoring environments. So I like to joke that within the DevOps movement, because monitoring is really such a big part of it, we actually have a sub-movement which is called Monitoring Sucks. And this is started by John Vincent, Lucy's on Twitter, and that's already over 2 years ago now, I think. Yeah, well, a year and a half. We had a topic on Twitter which was almost trending, which was monitoring sucks. And we tried figuring out why. What's the real problem? And there's so many open source monitoring tools around, and none of them really works. None of them really solves the problems you have, or you need to build tools around it, or you need to do a lot of things, or you need to hack around it. And that's basically a problem, because monitoring is important, and that's how there really is a sub-movement here. We have a Git repository where we are trying to list all the tools that allow you to do monitoring, that allow you to do metrics, that allow you to get data from inside the application. The funny part is that when almost 5 years ago we were doing research regarding open source monitoring solutions, we came to pretty much one conclusion, and that was that managing Nagios or Ikinga or another variant using a configuration management system is pretty much the only way to go if you want to have scale. And if you fast forward 4 years, that conclusion is still valid. So there's a bunch of new tools around, but if you want to build a really good monitoring solution, it's going to look something like this. And that's something you have to maintain. So you capture data on one side, you throw it over a transport mechanism. So here, for example, we have Java applications which have GMX exposed, you have system metrics, you have log files from Apache. You throw them using syslog or using different tools over a transport system to actually a tool that collects them, and then you get like log analytics, you get statistics, you get graphs, you get more graphs, you get time series database. And then the next thing is you have to build, the next thing you have to build is actually tools that allow you to visualize all of that. And yes, there are some tools that do all of that. They are sometimes open source, but trust me, they don't scale. They're fine for 5 servers. They're fine if you have a small or medium enterprise. But once you go at the level where you want to go, Facebook, Google, this doesn't work. That doesn't work anymore. The Xenoses and the Zabixes of this world are just too slow. And the Cacti, you need a full-time DBA to actually manage that. So, 4 parts. Collecting your metrics, collecting the log files, transporting them, doing stuff with it, and then visualizing it. And I have my favorite tools for all of that, of course. And I'll start with the part where we do the communication. And it's a weird tool to use for communication, because this is also written in Anger. This is a tool written also by Jordan Cicel. And originally, Logstash was just a tool for centralized logging management. It took log files from everything you can imagine, system logs, Apache logs, whatever, Nginx logs, shipped them centrally, throw them in Elasticsearch, and then you could query them and build statistics on top of that and learn from what was going on in your system. Logstash actually built a lot of input fields for that. And this is, in the meanwhile, way outdated. So you could get stuff from Reddit, from Stomp, from Syslog, from Twitter, from Jabber, from all kinds of different queuing servers. And then what you can do is actually mangle those log files. So there's a bunch of default filters where you can get the useless stuff out. And you can start counting, hey, we've got a PHP out of memory error. How many times do I get this an hour? We've got in a Drupal site, for example, there's Drupal logging, where you can figure out the exact log entries and make statistics based on that, figuring out the anomalies in your site. And it's much easier now to do that than going over 10 different servers, doing a grep on those servers, and then aggregating those data again, because that's pain. You really want to use this and just throw it at the developers. So these tools allow you to actually give the developer a backend API to Elasticsearch and let them build his own queries. And if he builds in good logging into his application code and he builds in good error logging, he can actually also build a tool which is going to throw more information than he has when he just has access to the server, and get that distributed over from different hosts right to his desktop, because he has full access to the data. And that's creating the feedback loop. That's creating a tool where developers can self-service, give the information they need to their coworkers, and figure out how to do that, all without actually having to go to a system administrator. So for example, these are all the failed logins and the successful logins over time, and we get nice metrics of that. But, well, that's not really a nice interface, right? This is what Logstash used to look like by default. Luckily, there's a new tool called Kibana, which makes that much, much nicer. For people that have seen Splunk once, which is a commercial version, Kibana is actually a Splunk killer. It's going to be much better. Now, for the PHP community, this is bad news, because Kibana used to be written in PHP, and as of one of the most recent versions, it has been completely rewritten in Ruby. Don't ask me why. There's a tool I didn't mention yet. Well, I mentioned it in the configuration management part, and that's Puppet. I've been using Puppet for ages now. It's my favorite configuration management tool for mainly the reason that I've been using it so much, and that if I want to switch to Chef or CF Engine, I need to rewrite a lot of things. And for pretty much all the tools I'm mentioning on my GitHub account, which is trivial first name, last name one, there's all the code you need to deploy this. So you don't need to reinvent all of this. You can just git clone, get the submodules, pull out the code, and play with Vagrant later. We'll be talking about Vagrant too. So one of the outputs that are here is statsd. And I want to have statistics on this. I want to have basically graphs on what's going on in my infrastructure. Who has sometimes used Cacti to get Graphite? Do you like it? Have you had a full-time DBA to manage it? The problem with Cacti is not only the configuration, it's also really heavy on database usage. But Graphite really makes graphing so easy. Any metric you can think of is a graph, and it's as trivial as basically sending a value, a string here, some value, the value you want to measure, and a timestamp to port 2003 of your server. You can all do that, right? In Shell, in PHP, in whatever. And then it gives you all the metrics you've collected, and you can have a dashboard where you can pretty much drill down in there, click, and enable, disable, whatever, and apply some function there. You can do math on there, you can do derivations, you can do all kind of funny things. You can have multiple graphs to each other. And all of this is actually, it's an API. Because if you look at the URL, the image that has been built here is basically something you can write yourself. So from within your application, you send a metric, you send multiple metrics, and from within another application you're building, you actually query that database and you visualize those metrics. And that's something with a lot of tools you cannot do. And that's something where a lot of developers I've been working with are really keen on, because they now basically, rather than having to go to writing a feature request, having somebody set up Cacti and do a lot of work, they can just say, create me a new metric, visualize it, without anybody else interacting there. So Graphite is also a really pluggable tool. It has a lot of friends. You can get stats from, for example, from Logstash, then use statsd to get a lot of statistics and send those to Graphite. But you can also use collectd, which does operating system level monitoring. You can have that with a lot of plugins. You can have them use Apache plugins, Nginx plugins, and get all those metrics and send them to Graphite. And that's the collection part. On the other side, Graphite also has a bunch of tools that allow you to build dashboards. One of my favorite ones is Gdash. And Gdash basically allows you to take all the Graphite components you have and write them again as code. Describe, I want to have a dashboard which contains me those three graphs. That, combine it, deploy it. And that's how you build dashboards these days. That's how you can actually, like if you are doing an e-commerce site, you can build a dashboard which gives you the current revenue growth, which gives you the number of people that are actually buying stuff on your site in real time without really having to spend a lot of effort on doing so. So you once again create a feedback loop, not only between developers and operations people, but really to the business also. Like with the previous tool, there's plenty of code online to actually build these things and do that automatically. So we talked a bit about culture, beer. We talked a bit about automation, about metrics, measurement. Let's talk about sharing. 15 years ago, when I was doing my first open source work, it was pretty difficult for a non-developer to share. Because what could we do? We could publish some documentation, do some trivial coding work, but really building the applications, that was stuff that wasn't really going on. These days, with infrastructure as code, we can actually, like this code, share what we're doing, share how much code and how you deploy software and how you do this. So we can actually open source a lot more work than we used to do. And with the introduction of GitHub, I don't know what I was doing without Git. I mean, CVS, Subversion. Git is giving us so much speed where we can grow and do stuff much faster. But sharing is also about talking about our experiences. I fondly remember a talk I gave in the UK a couple of years ago where I was talking about large-scale VM deployments. And in the back, the people from Google were sitting there, taking notes, listening how they were probably going to do stuff similar. And if you fast forward a couple of years, we see those same people now talking and sharing their experiences. Every DevOps Days we organize, there is going to be a big company explaining how they run operations, whether it's Booking.com, or it's Spotify, or it's Prezi. Those guys are now all talking about how to run operations, how to deploy software, how to do continuous delivery, and how to actually keep their platform up and running. So it is much more about sharing experiences and learning from each other, because the operational part is not the part which is going to make them bankrupt or make them go really big. It's the actual idea they have that it's going to be much more important to them. And if they can improve that by operational excellence, it's only going to be better. And part of that is the conferences that have been changing into more open space, more hallway tracks. There's conferences actually where I'd go to, not for the content of the conference, but really for the hallway tracks to get to talk to people. That is if my voice doesn't break down and I don't go down with a fever by 7 o'clock. So that's regular sharing. But there's also the thing about sharing responsibility for your software, and working together with developers on a shared environment. It starts with being able to build exactly the same environment where you want to deploy, and being able to give a developer something that looks really hard like what he's eventually going to deploy on. It's not having him develop on a Windows machine, then do some testing on Solaris and deploy it on Linux. But way too many people are still working like that. Lots of developers are working locally on MacBooks, and they're deploying on Linux, and then they figure out that internationalization is broken. Yeah, well, you're not developing on the platform where you're deploying. There's tools to solve that. If you've been reading the slides good, you've already seen me mention Vagrant. And Vagrant is, I cannot live without Vagrant anymore. Vagrant is a tool that allows me to manage a zillion virtual machines on my laptop without actually using any disk space, because the only thing that's on my disk is a Vagrant file, the actual code to build the infrastructure that's running in the virtual machine, and that's exactly the same code that I'm going to use to deploy the physical and the virtual machines in a data center, and the code from the software developer. It's an abstraction layer around VirtualBox, which is evolving because Mitchell is working on integration it with different virtualization products. But it's really small, it's fast, and it allows you to give a developer a box and say, look, the only thing you need to do is check out that repository, do Vagrant up, and you are running in exactly the same environment as the guy sitting next to you, and the guy sitting next to you, and the guy sitting next to you. And no, you won't have different versions of libraries. You will be running on the same Apache configuration. You will be running on the same MySQL configuration or Postgres configuration. And if within 3 weeks or 3 hours, hopefully, you want to go in production, you know that you don't need to go chase somebody figuring out why there's a different setting, because you are working on exactly the same platform. And that's so easy if you can work in a group of developers who are using those tools. A Vagrant file is pretty trivial. I'm sorry for showing actual Ruby code on a PHP conference, but you probably wouldn't have noticed. It's just a config file. It defines which machine you have, network, and which code you want to deploy on there. And you guys can all do this. Init, up, provision, down, destroy. That's the 5 commands you need to know. So what other tool do you need? What other thing do we like to share? I fear there's a broken image. But what else do developers and operation people like sharing? We already had beer, sorry. I'm sorry. Somehow the images got broken, but what do you do after beer? You go out for sushi and share a boat. And that's where, again, you start a conversation and you start discussing and you bridge the gap. So there's one really important tool which I forget, and My voice is breaking down, so you guys have to figure it out. What other tool did I forget?
Some way to sync data changes or schema changes at least? Database.
There's actually a bunch of tools out there to do schema changes. One way to approach this is to make sure you have backwards compatibility to version your schemas. Liquibase, for example, is a tool that allows you to do that. Liquibase, it's Java-based, but you could use it in any environment. It allows you to actually upgrade and roll forward your schemas. The Ruby community has that built into Rake. So, yeah, maybe the PHP community needs to figure out something that works for himself, but you guys could use Liquibase.
There's doctrine migrations works as well.
Yeah, for example. So there's tools already that do stuff like that. Anybody else want to give a shot at what really important tool I forgot? Deployment I basically mentioned by mentioning Puppet and Chef and CF Engine. But I know that it's only like a 50-minute slot, so I cannot go in depth into every tool and every talk. I could probably fill a whole day talking about this and which tools you need and what. But now the really big tool I forgot is basically you guys. It's still about you people needing to go talk to the system people and the systems people going to talk to each other. And it's about getting that conversation started. Not sitting both at the end of a building and not communicating. It's about going to sit together, go have some lunch together, go have some beers together, go have do some sports together and start the communication and involve everybody in the organization who's interested. And that's basically the most important part. It's not so much a technology problem. It's much more a human problem where you have to start a conversation and help out each other and reach out to people who want to learn. And that was basically what I wanted to tell you guys today. There's a bunch of links. The slides will be up later, I hope. And with that, I guess, questions? Or not? Yes.
What are your opinion of being a developer and being on call? That there are some recent movements that for a bigger development team that you are responsible for own.
I think that being on call is something that should be painless. And historically, the problem was that, well, if a developer just throws out software over the wall and doesn't care about what's going on, then it's the systems people's responsibility to figure out that the disks are flooding and the database is going down and all this stuff. And they get beeped, and they need to get somebody else involved then because they cannot really fix the problem. Why is this thing going out of memory? They don't know. Getting a developer on call means that he is going to be responsible too. He's going to need to fix it. And the change of mindset you get then is, well, first time you want to be called out of bed at 6 o'clock. The second time you're like, well, maybe if I write my code better, this is not going to happen. And then you end up being on call and not being paged. And that's basically also the promise of continuous delivery. If you have code that is being tested, that goes through a full testing chain, your quality of your code is going to be better. And then being on call is not going to be a problem because you know that the stuff you wrote, where you take responsibility, is not going to crash. So you shouldn't be afraid of being on call if you have done your job correctly. So I'm absolutely in favor to get developers on call, even only for a couple of months, to get them to make a change of mind where they figure out that, well, maybe we should improve the stuff we do. Yes.
There is apparently a lot of common points with business intelligence, where you business intelligence, which is about ETL build processes, extraction, transformation, and loading information
Mhm.
to some kind of cubes where you're defining your vectors and where you can analyze data and then reporting them with dashboards and so on. So it looks like there is a lot of common points. Is there some?
In the monitoring part,
Yes.
I think a BI tool is one of the tools that could be, you have to have the collection part somewhere, and those are metrics that typical ETL tools won't give you. You have to have the transport, but one of the consumers could perfectly be a Pentao or one of those tools.
Are BI tools typically used in
Nope.
this? Why, do you know why or?
Lots of people build their own dashboards. I've seen a couple of people looking into the BI tools, but it's not something you see going on there very often.
Okay, it's separate words.
Yeah. Yeah.
Is the effort too big for smaller organizations to keep these tools running?
So the question is if the effort isn't too big for small organizations to keep this running. I think the effort is not too big because if you don't do this, the effort of actually recovering is going to be much bigger. And the chance of failing if you don't do stuff like this is much higher. So obviously it's a matter of choice where you want to fail, if you want to fail late in the process or early in the process. But if you start building in a lot of tools up front, then it's going to be better for your organization in the end. And there's already so many things out there that have been automated where you can basically come in and drop a stack in a couple of days that it's not such a big effort. And it's not tools that you need to upgrade and manage on a daily basis. I have setups that are running already for a couple of years with these tools in place where, well, they work. Yeah. More questions or beer? Well, not for me, because